So example number 1, highlighting learning target number 1.6a. So looking at this first example, what we can see is that we have an instance where we can simplify this expression. I'm going to work it 2 different ways on purpose. The first way, I'm going to work it in order of operations. So we've got 34 times 102. Notice all that I have done is add inside the parentheses first using the order of operations. At this point, I'm going to multiply. The implication is multiplication now. So I have multiplication. 34 times 102 is 3,468. Now I want to compare that to distributing the 34 to all terms. When I distribute, the implication is multiplication. Okay, so 34 times 100 is 3,400, plus 34 times 2 is 68. Adding 3,400 plus 68 is 3,468. So we end up with the exact same result, whether we use the order of operations by combining what's in the parentheses first, then multiplying, or distributing, and then combining the like term constants. So hit pause and work the next 2 examples on your own. Actually, before you do that, let me work this next one because there is a variable included. Then you can work the last one on your own. So let's work this next example together. And in this case, what we have is we have a constant of 3 and we have a variable with a coefficient of 5x. These are not like terms, okay? So 5x and positive 3 are not like terms. Since they are not like terms, they cannot be combined by addition or subtraction. Excuse me. And so, since they cannot be combined by addition or subtraction, this expression 5x plus 3 is as simple as it will become inside the parentheses. So this is where the power of the distributive property comes into play, is because while we cannot combine these as like terms under addition or subtraction, we can distribute the 2 and simplify this expression further. And when we distribute the 2, what we are going to do, again, is multiply. So we're going to multiply the 2 times the 5x, and then add that to the 2 multiplied by the 3. Again, it does not matter which direction we're distributing, whether from before the parentheses or after, we're still implying multiplication. Now, when we multiply the number 2, by 5x, remember the 5 is our coefficient. All we are going to do is multiply the 2 by the coefficient. So 2 times 5 is 10, and then the x goes along for the ride. We do not multiply by the x. We do not multiply that 2 by the x as well, because we have an implied multiplication already between the 5 and the x, And using the associative property, we could multiply the 2 times the x and then back by the 5, which we would still end up with 10x. And so what we are going to do is just multiply the 2 times the 5, and then knowing that that x is a variable, we will leave it there as a placeholder until we have a number that we want to substitute in for that variable x. Multiplying the 2 times the 3, 2 times 3 is 6. So 2 times 3 is 6, so now we end up with the expression 10x plus 6. And so the question I ask is, are 10x and 6 like terms? Well, this is a term. The plus 6 is a term. Do they have the exact same variable raised to the exact same power? Well, x is the variable in 10x. 6 does not have a variable, so they do not have the exact same variable, so they are not like terms. For that reason, we have a simplified expression of 10x plus 6 as our final answer. And so in the example number 2 to the right, I'm not going to work it out completely, but it does not matter which direction we distribute it from, we still end up with 10x plus 6 as our final simplified expression. Now, I would like for you to hit pause and see if you can work example number 1, part 3. Okay, looking at this example, number 3, I'm going to go ahead and distinguish my terms. I've got a 7x. I have a plus 2. Remember, it's an implied plus. A plus 8 and a minus 3. The 2, 8, and 3 are like terms. Therefore, I can combine them inside the parentheses, so I could say 7x, and 2 plus 8 is 10, minus 3 is 7. And then I can just multiply the 7x times the 7. Now, technically, I am distributing here. Technically. And since I am distributing, I am multiplying. And once again, when we multiply with a variable coefficient, the coefficient times a constant, so I've got the 7, and then I have the other 7 as my coefficient. I multiplied those two by each other, bringing the x along for the ride, and 7 times 7 is 49. And then the x continues to be a variable placeholder until I want to substitute in a value for it. And so 49x is the simplified expression. Looking at the part 3 on the right, once again, I could use the same methodology of highlighting my terms. I've got 3 like terms, but in this time, instead of combining my like terms, I'm going to distribute the 7x. And once again, when I distribute a term with a coefficient, I'm just going to multiply the coefficient by the constant. And so I end up with 14x plus, and then we have 7 times 8, which is 56. Remember, a positive times a positive is a positive. The x continues to come along for the ride. And now I have a minus 3 times 7, which is a minus 21x. Looking at this expression, I can now see that I have these as my like terms because they all have a variable x. All the variable x's are raised to the first power. They are the same variable raised to exactly the same power. Therefore, they are like terms, and I can combine them. And when I combine them as like terms, what I will say is 14 plus 56 is 70 minus 21 is 49. And I'm going to do something here just to highlight a particular point I want to make. When we combine like terms with a variable through addition and subtraction, we do not change the value of the exponent of the variable. It remains the exact same. So that x stays the same, exponent and variable, as the x in the terms that we were combining. And so in combining these like terms, we have added the coefficients, and in the case of the minus 21, we added the negative, and then the x maintains its same properties as far as the variable and the exponent. Notice finally that despite distributing first or using the order of operations, my two final answers are the same.